Thank you, everybody. It's really nice to be here. I'm very excited, and I really want to thank the organizers for putting everything together so well. It's really an honor to be here. Thank you for that. Right, so our story starts in Vienna, which also happens to be my favorite city. It's also the city with the city hall where I wanted to become the first lady mayor when I was around 18, which is when I first visited the country. And so the story begins somewhere last year. It was in May. I was attending We Are Devs conference. I was hanging out with a bunch of really, really cool people. They're really some of my favorite friends. But today we're going to focus especially on this guy. And if you don't know him, you really should. That's Martin. He's the most amazing person I know. And so, we were at We Are Devs, and we were talking, and Martin and I go a long way back. We've had our share of parties and dancing together. And so we have a thing in common. We both like web components. We really believe in web components, and we were talking a lot about it, and he's working with it, and I was giving talks about it and working with it a little bit. And so he takes me aside and he said, Carmen, I really want to show you something. So he pulls me aside and he opens his laptop and he starts coding. And he was like, so this is A-frame. And we're going to build something together with it. And then, it's like one custom element after the other. And in no time, we had this running app. And I was like, and it really hit me because I was always talking about web components, but somehow when he used it and I saw the power of it, it was like the coin dropped for me. I was like, yeah, it makes total sense now. So if you fast forward that to today, it was like, so how cool would it be if you could do with web components what A-frame does, but then pour that to machine learning? And this brings us to our talk today, which is smart angular elements. And it's an experiment for me because I had no idea what would be possible with it, but I really, really wanted to try it because I find it to be a very, very good idea. So I'm Carmen. I'm Carmen Popoviciu on Twitter. I work at a really cool company called Creative AI with the most amazing team I had ever had the pleasure to work with. I was thinking, how should I go about this talk? Should I just go there and prepare a big bunch of slides and then just, go and explain things? But then I thought it would be much cooler to just have a demo where we can see how these things work together. So I prepared a demo, and we're going to do a bit of live coding, and at the end I have a small surprise for you. But before we do that, I just want, with a quick raise of hands, I want to know how many people are familiar with web components? Okay, so for those of you who aren't, web components is basically a web standard that will allow you to do something like this, right? So you can just have a custom HTML tag, in this case, Sachertorte. Does everybody know Sachertorte? Oh, it's the cake that you eat. It's the Vienna cake. So if you ever go to Vienna, you have to eat the Sachertorte. So this is basically what web components allow you. They allow you to create custom elements that the browser will understand. Now, who is familiar with machine learning? All right, so for those of you who aren't, a very, very, very quick intro to it. There are many types of artificial neural nets and a lot of machine learning algorithms. But I'm just going to stick to a very, very basic example because you will need it in order to understand a little bit of how our demo works. So think of this. Think of image classifier, right? You have an image, you have an artificial neural network, and you would like the network to be able to predict what the image is, right? So if you have an image of a dog, you would like the network to be able to tell you this is the image of a dog. So what this means is that you have the network, you feed it an input, which is the raw image data, right? It's the pixels, and the network will output something. It will output whether it's a dog or not, for instance. Now, in order to do that, you have to train this network. So you have to show it a lot of images in order for the network to understand what a dog is. And so each time you train this network has a state. And this is very important. This state, this internal state, is characterized by what we call weights and biases. Like, really take a snapshot of this. This is really important, right? So what it does is you feed it the raw image data, it does the processing, and then it outputs its prediction. If the prediction is correct, thumbs up. If the prediction is wrong, then what the network will do is it will go back through its internal state, and it will update it so that with the next pass, it will recognize that image, right? So it will update its internal state, it will update its weights and biases. That's about it. I don't want to go too much into detail because it's not so much in the scope of our talk. But in a nutshell, this is kind of how I think about it. So let's start the demo. So the demo is going to be about generative art. And for that, we're going to use an algorithm which is called CPPN. I don't want to go into the details of that. The link is in the slides, but basically you can produce images like this. This is the work of David Ha, which I have a lot of respect for. He has a lot of articles about this. I really recommend it. But this is basically what we're aiming for. So does everybody see this all right? Okay, right. So let me show you what we have so far. So we have an index page. And so we're going to start with a very basic component, which I have already prepared here. I'm not going to go into the details of how all the machine learning part is implemented. That's up on the GitHub repo, and you can have a look over there. But I have this ngArt component, and I want to show you what it does. So I have this component, layers, and it takes a couple of parameters. So it takes the number of layers of the network. It also takes the activation function, which I didn't tell you about, but just trust me on this one for now. Right, so I think this should be it. And so this is an Angular component. And what I want to do is I want to use it as a custom element, right? So then in order to do that, I'm going to add it to the declarations of my module and add it as an entry component, because this component is going to be dynamic, right? So let's see if this works. Probably. Okay, this is compiled. And of course it doesn't. The value is 0. Oh, right. Let's see. ngArt. Oh, yes, of course. Sorry, I forgot the most important parameter, which is the canvas size, and that's going to be 128. So let's see if this works now. Right. So this is our starting point. This is our ngArt component, right? And this runs as a custom element. This is not an Angular app. It has nothing to do with it. But we did use Angular elements to create this custom component. So let's do, well, I mean, that doesn't do very much in itself. So let's do something else. Let's add some controls to this. Controls. Right, and then let's wrap this in a div, and then say class, this is container. So let's add some controls to it. Class container and an art div container. Well, so much for preparing the demo. Yeah, demo god. Oh, right, of course. Oh, silly me. So what I have here is I have a sidenav component, and this sidenav component uses a slider so we need to add the slider to our entry components. And this is the material slider. And it also uses an icon, so we need to add the icon as well. We're not declaring that, but in order for that to work, we need to add that dependency to our imports. So we're going to use mat slider module, right? And then also mat icon module. Is it there? Mat icon module. Yes. So let's see if now it works. No, it's not. Here? Oh. Thank you. Yay, live coding together. Nope. Right. No, still no. Why not? Side nav, entry components, mat slider module, mat icon module, elements, and art, mat slider, mat icon. I'm not really sure why this doesn't work. Side nav, controls, container. Okay. I'm sorry for this. I'm not sure. Well, so I'm sorry. I'm not sure why it didn't work, but this is how it was supposed to look like. And so if I go back to the index page, sorry, the main TS. Here are a couple of things that we're doing. So we're selecting an NNArt component, and we're also selecting the slider and the input. And what we're going to do is, every time there is a change event in the slider, we're going to update the attributes of the NNArt component. And we're going to do the same when the input value changes. So what this looks like is something like this. So notice that the animation, that the generated image changes, its quality changes, because we're increasing the number of layers in the network. What we can also do is we can change the activation function, and this would look like something like this. Or we can do relu, which is one of my favorites. And then do something like this. So this is what would look like. Is everybody following so far? I mean, is it clear what we're doing? Cool. Right. So let's do something even cooler than this. Let's do, and this, I would not have time to live code this, so I'm just gonna cheat again. But let's assume you would have another custom element that is machine learning based. Let's assume that instead of the traditional slider and input controls, you could have something like an input field where you could just draw digits, and then you would have a neural network that would recognize that. And I thought that would be a very, very cool idea. And so I worked really hard on that, and then I made it happen. So let's have a look at, first of all, let's have a look at how that looks like. And see if it updated. Right. So let's say we draw a 3. Notice that the predicted value is 3. This still works. We can still do this. We can refresh. It's going to crash now because there's a lot of computation being done on the GPU. And the memory is really polluted. I'm not entirely sure what causes it, but it's enough to, I'm happy that I have this thing working as it is. So let's have a look at what this looks like. So here's how we made that work. I took a pre-trained model of an MNIST network, of a neural net trained on the MNIST data set. And what I'm basically doing is I'm creating a network, I'm training it, and then when you're training that with TensorFlow, TensorFlow can take a snapshot of that inner state of your network. Remember, the things that I told you are really important, like the weights and the biases. So TensorFlow can take a snapshot of that. And then what I can do is I can take that snapshot and then initialize a network in the front end with those weights and those biases. So that means that I have a neural net which is already pre-trained on that data set, but I'm not doing the training on the front end side. You could, but I'm not doing that at the moment. And so how that looks like that model snapshot is, like, notice the biases and the weights here, right? So this is the model data. This is what I can use to initialize my network. And so what I'm doing here is, and I'm using the deeplearn.js library for this one. So I have this model snapshot. And so what I do is I'll read it. And then once I read everything that's in it, I can create my model, my local model, right? And so what happens is when I have the canvas and I'm drawing the digits on it, I'm calling this predict method, right? Because I want to predict what, like, take the data, the raw image data of what you've drawn. I want to feed it through the network, and I want the network to tell me, okay, that's a 3, or that's an 8, or that's a 1. Right? And this is basically the code that does that. The prediction itself is pretty straightforward because you have the neural net, and the neural net will just, like, take the raw data and it will just pass it through it, and then it will just output something. The tricky thing here was, however, getting from the canvas raw data to a data format that the network can work with, right? So this was a bit the tricky part, and this is basically what we're doing here. If you want to know more about that, come pick my brain, because I've spent a lot of time on trying to understand this monster. Right, so, but this is what basically happens, right? And so there are two ways to go about this, right? So you could go the way that I did. You could train the model somewhere. In this case, there's a Python script that I'm just running, and I'm training it locally. This can work just fine. You can also create the net straight in JavaScript and just do the training there, because things nowadays work with on GPU, so that there's not such a big performance loss there. But my point is, and the thing that I would like everybody to take with them is that, this could really be a thing. You could really have custom elements in which you have, like, machine learning algorithms that you could just drop a tag in your index.html file and it will just work, right? And I find this very, very powerful. And I don't know, it's just, to me, it was really that moment when Martin and I were talking, and I was like, yeah, I would really like to see this. And I'm really happy I got this demo to work, because it was really a challenge. So, to end that, the demo is right over here. It's on GitHub. Do come to me if you have any questions. I'm very excited about this, so I'm very happy to talk about it. Follow Martin on Twitter. He's the coolest guy ever. And to end it in a very nice way, I'm just going to leave you with this.